Alright guys, so we are going to start the unit on factoring. We're going to look at this quick little puzzle here. We're going to complete each puzzle so that the sum of the two sides equals the top number. So that's going to be adding. So this is going to be our sum is the top. And the product, multiplying, of the two sides are equal to the bottom number. So this is going to be our product. Now, if you find one of these online or another teacher's giving you one in the past, it's according to who designed these. So it does not matter if you're multiplying on the top or the bottom, because this particular worksheet is set up this way. We're going to add to get the top, multiply to get the bottom. And so sometimes they switch that around. Okay, so 4 plus 3 is 7. 3 times 4 is 12. Negative 7 plus 2 is negative 5. Negative 7 times 2 is negative 14. Negative 2 plus negative 3 is negative 5. Negative 2 times negative 3 is positive 6. So this is where those mental math skills really are helping. So if you're weak on this, then that might be a struggle in this unit. So you're going to need to practice some of these. So negative 3 times negative 6 is positive 18, and negative 3 plus negative 6 is negative 9. Okay, 8 times negative 3 is negative 24, and 8 plus negative 3 is positive 5. And we can keep on going and going. So let's look here. Sometimes they give us this. So what plus 3 gives me 12? That'd be 9. 3 times 9 is 27. 3 times what gives me 12? 4. 3 plus 4 is 7. Then they change it up, but we got a little negative here. So negative 2 plus what gives me negative 8? So negative 6. Negative 2 and negative 6 is negative 8. Negative 2 times negative 6 is 12. Okay, negative 20 divided by 4 is negative 5, and 4 plus negative 5 is negative 1. Okay, let's look at one more. Down through here, let's see if there's one. Okay, so let's look at this one here. Okay, so 16. You may think, oh, that's 8 and 2. Okay, 8 times 2 is 16, but is 8 plus 2 8? No. Is 8 minus 2 8? No. So then we have to ask, what are other factors of 16 that will give me 8? Well, 4 and 4 are factors. 4 times 4 is 16. 4 plus 4 is 8. But 4 plus 4 is not negative 8, so they both need to be negative, and that still gives me the positive 16. All right, so I'm giving you some here to practice. I do have the answer key if you want to check it. Practice this. This will just help you with your mental math. Okay, if you will turn your notes and find this page, we're doing Intro to Quadratics. Now, we have talked about quadratics before when we did naming our polynomials, and we know that quadratics has a degree of 2. Okay, so a quadratic function is a function in the form of ax squared plus bx plus c. Okay, so we're going to talk about this. Don't look at all those letters and get all frustrated, because we're going to talk about it, and we'll be using this a lot, and you will use this throughout your mathematical career. This is in standard form. We know that because it's in the highest degree to lowest. Okay. Characteristics include 3 distinct terms, 1, 2, 3 terms, each with its own coefficient. So what do you know about coefficients? We know that it is the number being multiplied with the variable. Okay. An x squared term with the coefficient. So what would the coefficient be here? A. Okay, so that represents a number. An x term with the coefficient b. And then we know c doesn't have a variable, so that is a constant term, and it is going to be c. So note, if any term is missing, the coefficient or the constant of that term is going to be 0. So you don't just forget about it. If there's not a b, b is 0. If there's not a c, c is 0. If there's not an a can be 0. Okay, so here we're going to identify the coefficients a, b, and c. So what number is in front of x squared? 1. What number is in front of x? 4. And then what is my coefficient? -2. Remember, the sign stays with the number. Okay, here, what number is in front of x squared? -3. What number is in front of x? -2. Do we have a coefficient? No. So when we don't have something, remember, we can list it as 0. Okay, this is not in standard form, so you can rewrite it in standard form, and that will help you do your A, B, C. So my A here is 2. My B, do I have an x? No, so 0. And my C is -5. Okay, so we will be using this throughout this unit. So make sure you understand the A, B, and C. Okay, you should have heard of greatest common factor in your middle school. So greatest common factor, first of all, with variables, the greatest common factor will always be the smallest or the lowest exponent. Smallest exponent of the common variable. Okay, greatest common factor, GCF, greatest common. So something has to be in common. So steps to find the GCF. You find the GCF of the number and pull that out first. Then pull out the smallest exponent of the variable. Must be something they have in common. Hence, greatest common factor. Okay, so let's look down here and let's just talk about finding the GCF. If I look at 12 and 16 and I ask myself, what is the greatest number that are going to 12 and 16? So at first you might think 2. But then I have to ask myself, what else will go into that? And that is 4. So a 4 divided into 12 and 4 will be in the 16. And that is the biggest number that are going to both. Then we're going to look at our variable. They both have an x. And then we're going to take out the smallest exponent. Well, here the exponents are equal, so I could take 2 x's out of each term. Okay, so let's go to this one. We have 45 and 50. So what is the greatest number that are going to 45 and 50? And hopefully you thought of 5. And then they both have an a. And then I'm going to look at the smallest exponent, which is 5. Okay, here on number 6, example 6, what are going to 5 and 35? The number 5. 5 has an a, but 35 doesn't, so I cannot take out, because this is like a to the 0, so there'll be no a's to take out. Okay, let's go do just a little bit deeper here. Okay, remember when you are factoring, nothing disappears, they merely get rearranged. So when you factor something, you should be able to check it by multiplying. All right, so step 1, we're going to find the GCF. So we're going to find the greatest common factor of all the terms. It must be something that can go into each term. We're going to write the polynomial as a product by dividing that GCF from all the terms. Whatever is left over or remaining will form the polynomial. Okay? So your answers here, so let's look here and let's ask ourselves, what are going to 4 and 6? So my GCF here would be 2. One has an x, one has a y, so they don't have a common variable. So 2 is the GCF. Now we're going to take it a little bit further. We're going to divide each term by the GCF. So we're going to have 4x divided by 2, 6y divided by 2. Now we can't just throw that 2 away. So we have to write the 2 out in front, and then we're going to divide. 4 divided by 2 is 2 with an x. 6 divided by 2 is 3y. Now, how can I check this? I can use the distributive property to check. 2 times 4 is 4x. 2 times 3y is 6y. So notice, I didn't change the problem. I just rearranged it. I wrote it in a different way. I wrote it where I am multiplying here, but this would give me the same polynomial to begin with. And we're going to talk about why this is important later. Okay, so here, the GCF, if we look at it, what are going to 6, 9, and 12? 3. This has an x, this has an x, this has an x. So an x can come out. 3, 2, or 1, so 1's the smallest. All right, so we're going to rewrite it here, and we're going to divide by 3x. Now this will get easier as you get used to it. You will not write this step. You will do it in your head. Okay, again, I can't just throw that GCF out. I have to write it down and keep it, or it changes my problem. If I had thrown this one away, I would have 2x plus 3y, but I wouldn't have the 2, so it would not be the same as the original problem. So we're not trying to change the problem. We are trying to keep it the same, but writing it in a different way. Just like if you have the number 6, it can be written as 2 times 3 or 1 times 6. That didn't change the value of 6. We just wrote it in a different way. All right, 6 divided by 3 is 2. What do you do with exponents when you're dividing? That's right, we subtract. So 3 minus 1, taking 1 away from 3, so I got 2. 9 divided by 3 is 3. 2 minus 1, 1. 12 divided by 3 is 4, and the x's go away. Again, if I check by distributing, 3 times 2 is 6. And then when I multiply, I add exponents, so x to the third. 3 times 3 is 9, x squared. 3 times 4 is 12, x. All right, let's look at this number 9, GCF here. So 2 and 2, h, no h. K and k, so I can take out a k. So I have 2h squared k plus 2k. I can divide by 2k. So remember, I have to write down my GCF. I can't just throw it away. The 2's cancels, the k's cancels, and I'm left with h squared here. The k's cancels, the 2 cancels. What's 2 divided by 2? That's right, 1. So that will leave me, if I multiply it back out. Had I forgot this 1, let's look at this. If I'd had 2k times h squared, and I just said, oh, that canceled out, it's gone. Would that give me my original problem? No, it would only give me the first part, so this is not correct. All right, so I wanted to show you this that we did earlier. I wanted to show it to you the way sometimes you'll see it. So here you find two numbers whose product is the top. So this one, the product's the top. Okay, so that means I'm going to multiply to get the top. And whose sum is the bottom number, so I'm going to add to get the bottom. So what number will multiply and give me 40 and add to give me 13? 8 and 5. All right, if you'll stop the video now and then do these next two and come back and check yourself. All right, so hopefully you got negative 12 and positive 6 to give you negative 72. And then 6, is that correct? No, the 12 can't be negative. The 12 has to be positive, and the 6 is negative. Trying to see if you're paying attention. All right, so then here we have negative 6 and positive 4. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. So watch your signs. Okay. So we're going to do this on the, we'll talk about this later. Okay, so if you're in class and we have time, we're going to do this page and do some GCF. So please make sure you understand this because it's going to be important for what we learn tomorrow. Check your plan book. Have a great day.